Herstein, Abstract Algebra, Chapter 2, Section 1, Problem 6. Let G and H be, as in example 6 and 7, and we're going to show that this new element belongs to H. So what are these G and H here? So remember, we've seen this in a couple of our videos. G is a mapping of this form. So that to define an element of G, we need to say what lowercase a and lowercase b are, and that gives us this mapping AR plus B. So an element of G is a mapping. So it inputs all of the real numbers, and for every real number you give it, it outputs another number, which is AR plus B. Now, we have multiplication defined for this group, because every group has a defined multiplication. So given two such mappings, this third mapping is their product. So that's the group G, and then the subgroup H is exactly the same as G, right? Because all of its elements come from G, except now we restrict such that A is rational and B is real. Whereas before, we were allowing A and B to both be real numbers. So let's look at how we can make sure that when we combine these three elements, we end up with a member of H. This is our definition of group. Of note, we're going to use the associativity property for this problem. And then a quick reminder that if we take sums and products of rational numbers and real numbers, the output will be a real number. So let's go ahead and do this. Now, in order to show that this new element is in H, we need to know what the inverse of TAB is. We can see from example 6 that the inverse is this. It's T sub 1 over A, comma negative B over A. We could have also solved for this using property number 4 in the bottom left there. You could set those two elements, T, A, comma B, and then its inverse equal to the identity, which is T sub 1, comma 0, and solved for it. But earlier in the book, it just gives it to us. So this will be our inverse element right here. And all we're going to do is show that this new element belongs in H, which is equivalent to just showing for H, we look at what do we need to belong to H. We just need the first number to be rational and the second number to be real. In our first line here, we just use associativity. We can multiply this in any order we want, so I multiplied the first two elements first. Here we have T sub A comma B is any member of G, and then T sub C comma D is any member of H. And what that means is that we have that A, B, and D are real, and that C is a rational number. So just following our formula for how to multiply, which was given to us in the group, remember every group comes with its multiplication, we just literally solve this here. So to get AC, we just follow the formula, and to get AD plus B, we just follow the formula again. And then we multiply in our second line here, we multiply those two elements. So for example, our formula tells us the first indices should be AC. Well, here instead of A, we have AC already. So it's the first times the third. So AC times 1 over A. And then our formula tells us AD plus B. So it's the first and the last, which is AC times negative B over A, plus the second into C, which is AD plus B. So all said and done, we can cancel out a little bit, and this is what we get. Is this mapping an element of H? We know it's an element of G. Why? Because G is closed under multiplication. That's our first property of groups. So it has to be a member of G. The question is, did this element land in the subgroup of G, which is H? Again, to be in H, what do we need? We need that A is rational, the first indices is rational, and the second indices is real. Is the first indices rational? The first indices is C, which we know by assumption C is rational. The second indice needs to be a real number. Is this a real number? Well, it's the sum and product of rational and real numbers, so it is a real number. Therefore, we know that this new mapping is an element of the subgroup H, and we finished our problem. Thanks for watching. I hope you've enjoyed the video. Don't forget to subscribe so you don't miss out on future videos. If you have a question about this problem or you'd like to request a solution to a different problem, make sure to leave a comment below.